In this video, I'm going to differentiate these functions of one variable that I have written here. What I've done is I have created a live script and then typed in this text. So the next step now is to enter the code which differentiates those given functions. So for the first one, I'll go here, press the return key, then indicate that I want to enter my code. So for the code there, we are having a variable x. So I'll create a symbolic variable, syms, symbolic variable there. Then enter the y that we are having. I'm having different y's there, this one and this one. So I'll call the first one y1. So y1 is equals to, and it's x, then to the power 2. So this is the y squared there. I can just run here so that we can just see. So it's saying y1 is equals to x squared. So our question is now asking us to evaluate the derivative of y with respect to x. So I'll just press the return key. For the derivative of y with respect to x, the command that we use is diff f. It differentiates f with respect to the default variable. In this case, we are just having one variable, the x there, so it will differentiate the function f with respect to x. So I'll call that d1 is equals to, then we are saying diff, then open parenthesis, we put inside there what we want to differentiate. We want to differentiate y1. Then I can go on and run there. So it's giving that our derivative there of the y1 is 2x. The next question is asking us to evaluate that derivative at x equals to 3. So what I can do is I can press the return key there. So the command that I will use there is subs. I'll open parenthesis. So we are saying we are substituting into what? Into d1, our derivative. And we are replacing what with what? The old, we are replacing the x, then comma, then put what we are replacing x with. We are replacing x with 3, because we are saying x equals to 3, so 3. So I'm done there. Then I can go on and run. So I can just give this a name to say it's s is equals to subs. So that when it comes out, the answer here to have our s there. So it would have s is equals to 6. Because what it did is it substituted where we have the x there, it put a 3. So the command that you use is subs. Then you put in the function, the old value, we are saying x, where we had x, we are replacing with the new one, 3. I now go on to the next one here. This one, y is equals to exponent of x sine x. So I can just press the return key there, indicate I want to enter the code there. So we now enter our y. So this is the second y, so I will just call it y2 is equals to, or the exponent of x is exp. So open parenthesis, x. Then we are multiplying it by sine x. So I will say multiplied by sine of, open parenthesis, x. I can just run so that we see the function that we have just entered. This one, y2 is equals to exponent of x sine x. So I can click here, press the return key. Now differentiate the function y there. So I'll call it d2, the second one. So it's d2 is equals to diff. We are differentiating now y2. So for the derivative of y2 there, I can go on and run. And it gives us exponent of x cosine x, exponent of x multiplied by sine x. That's the derivative of this y here. On this part here, it's asking for the second derivative. So for the second derivative, the command that we use is diff fn. It computes the nth derivative of f with respect to the default variable. So in this case, we want to differentiate this one here with respect to y, the second derivative. So I'll call that d2b is equals to, then is diff open parenthesis, we are differentiating y2. Then comma indicate is the second derivative, so comma 2. Then I can just go on and run. So we are finding the second derivative of y2 there. And it gives that the solution there is 2 exponent of x cosine x. So I will now go on to the third one there. This one, y is equals to 2x divided by x squared plus 1. And we are going to evaluate the derivative of y with respect to x. So I can click here, press the return key, then indicate I want to enter the code. So for the code there, the y, and this is the third one there. So I'll call it y is equals to 2, then multiplied by x, then divided by, open parenthesis, x to the power 2, then plus 1. So that's our function there. I can just run, just to confirm that I've entered the correct one. So we have our y3 is 2x divided by x squared plus 1. Then go on and differentiate it. So I'll call this my d3 is equals to, then for differentiating, we are saying diff, open parenthesis, then we are differentiating y3. So it will differentiate with respect to the default variable. We are just having one variable x there, so I can go on and click run there. And we have the derivative there is 2 divided by x squared plus 1 minus 4x squared divided by x squared plus 1 squared. I can now go on to the next one here. Y is equals to ln of x squared plus 2. Then we want to find the derivative of y with respect to x. So I press the return key there, code, so that I enter the code. We are saying this is the third one there, so I'll call it y4 is equals to. Now, when we are in MATLAB, the command for the natural logarithm, the ln here, is just log. So it's log, then open parenthesis. But if you want to use the log base 10, you would specify that it's log base 10. But if you just write it as log here, it gives the natural logarithm, the ln that we are having here. So what we are having there is ln of x squared, then plus 2. So we have our function there, log x squared plus 2. I can just run to just check. So it's log x squared plus 2. I can go on and now and differentiate this one. So it will be my d4, and we are saying is diff, and we are differentiating y4. So go on and run there, and it gives us that the derivative there is 2x divided by x squared plus 2. So that's the derivative of this given function here.